For our next example, we will prove that square root of 2 is irrational using a proof by contradiction. So to start with, we'll let p be the square root of 2 is irrational, and we will suppose that not p is true, meaning square root of 2 is rational. As we commonly do, we will start with the definition of rational. If square root of 2 is rational, there exists integers a and b with the square root of 2 equals a over b, where b is not equal to 0, and a and b have no common factors. In other words, it's in its simplest form. Our first start of actually solving the proof is to write the assumption, square root of 2 is equal to a over b. Next step is we'll square both sides. Squaring both sides gives us 2 is equal to a squared over b squared. The next step is we move the b squared over to the other side, leaving us with 2b squared equals a squared. And this means that a squared must be even, since it equals 2b squared by the definition of even, because 2b squared is 2 times some number. That is the definition of even. Now, using the definition of an even integer, we can say that a is equal to 2c for some integer c. We don't use the same letter a because we want to indicate that we are doing some sort of a substitution here. So that's why we don't use the same letter and keep that consistent throughout. Now we'll go ahead and multiply the 2c by 2c, giving us 4c squared. And then we'll divide both sides by 2, leaving us b squared is equal to 2c squared. And we'll move this up a little. Uh-oh, looks like my app is locked here, so I'll pause this. Okay, I got my app restarted. And now I can scroll it up a little bit, and we can say, after doing this division, that b squared is even, because it is in the definition of an even number. Namely, it is 2 times c squared, 2 times some number. Since both a and b were even, we have the square root of 2 is equal to an even number over an even number. Since a and b are both even, that means that 2 can be factored out of each, meaning that this was not in simplest terms, contradicting the definition. Therefore, the square root of 2 is irrational.